The summer of 1950 was supposed to be peacetime. Instead, American tankers in South Korea were watching their 75mm rounds spark off Soviet steel at ranges where the answer coming back could kill them clean. The M24 Chaffee was a reconnaissance tank, never meant to fight in the line of battle. But when North Korean T-34/85s, supplied and trained by Soviet sponsors, crossed the 38th parallel, the Chaffee was what we had. 38mm of hull armor against an 85mm ZISS-53 that had been engineered to kill Panthers. Crews called for support that couldn't stop what was already on top of them. Rounds bounced. Men died. The Pusan Perimeter contracted. This wasn't a failure of courage. It was the price of demobilizing too fast and assuming the next war would announce itself on our terms. How America answered that crisis, in metal, doctrine, and blood, is exactly what we're covering today. Subscribe so you don't miss a single frame. What happened in Korea didn't occur in a vacuum. It was the direct consequence of decisions made 5 years earlier, when the United States dismantled the most powerful armored force in its history, with remarkable speed and very little strategic foresight. By 1950, the Army's primary armored presence in the Pacific theater was the M24 Chaffee, a 12-ton reconnaissance vehicle doing a job that required a 30-ton medium tank. The equipment that could have answered the T-34 was sitting in motor pools stateside or already scrapped. Meanwhile, in Europe, the Soviets weren't demobilizing, they were building. The IS-3 heavy tank had appeared at the Berlin Victory Parade in 1945 and stopped Western military observers cold. Its pike nose hull and massive 122mm gun represented a generational leap that nothing in the American inventory could reliably defeat. The follow-on T-10 pushed that threat further. The Army's response was the M103, a 65-ton heavyweight mounting a 120mm gun designed specifically to outslug Soviet armor at range on the North German plain. But Korea needed a solution now, not in 5 years. The T-42 medium tank program, which represented the Army's vision for next-generation armor, wasn't ready. So engineers mated the T-42's turret to a modified M46 hull and called it the M47 Patton. It was institutionalized improvisation, and everyone involved knew it. Most M47s were shipped directly to NATO and SEATO allies through the Military Assistance Program, arming West Germany, Italy, and South Korea, while the Army quietly accelerated work on the M48 it actually wanted to field. The answer to the crisis was being engineered, and it was being engineered fast. The M46 Patton was where the lineage genuinely began. Its predecessor, the M26 Pershing, was a capable gun platform hamstrung by an underpowered engine that left crews white-knuckling it up anything steeper than a moderate grade. The M46 fixed that decisively. The Continental AV1790 V12, producing 810 horsepower and paired with a cross-drive transmission, gave a 48-ton tank an agility that genuinely surprised Soviet advisors, who had assessed Korea's steep terrain as a natural barrier to American armor. It wasn't. At the bowling alley and along the Noktaung Bulge, M46s were engaging T-34s/85s reliably past 1,000 yards with the 90mm M3A1, and winning those exchanges consistently. The M47 followed, and it deserves credit before it gets buried. It was the first American tank to integrate a ballistic computer and an internal rangefinder into a production turret, a genuine technical leap. But mechanical immaturity undermined it in service, and the Army never truly committed to it. Most went directly to MAP allies. It was a bridge, and everyone who built it knew that. What the M47 introduced in fire control philosophy is worth pausing on. Its stereoscopic rangefinder required the gunner to possess near-perfect stereo acuity, the ability to merge two offset images into precise three-dimensional depth perception. In peacetime, on a range with a rested crew, that system worked. Under sustained combat fatigue, stereo acuity degrades measurably. Gunners were missing targets they should have hit, not because of poor marksmanship, but because the optics demanded a physiological precision that combat systematically erodes. The M48 A2C addressed this directly by transitioning to a coincidence rangefinder. theoretically less precise at extreme range, but dramatically more consistent for the average gunner operating under stress. That was the correct trade. The M48 series itself evolved through hard operational lessons. Early gasoline variants, the A1 and A2, earned the nickname Ronson for reasons any veteran will recognize immediately. Puncture a fuel line or a hydraulic fitting, and you had seconds, not minutes. The M48A3's conversion to the AVD S17902A diesel engine changed that equation fundamentally. It wasn't merely about fuel economy. It was about a 300-mile cruising range that allowed armored cavalry units to operate deep in the Central Highlands without chaining themselves to a gasoline resupply convoy every 48 hours. The A3 also carried the AN/VSS-1 Xenon searchlight, and if you've never looked closely at how that system actually functioned, it's worth understanding. 100 million candle power output with a motorized infrared filter, a precision-coated glass cylinder that slid mechanically over the xenon bulb, blocking visible light while transmitting infrared wavelengths through the gunner's IR scope. The enemy, lacking night vision equipment, was operating in absolute darkness, while the Patton's crew acquired and engaged with full situational awareness. The operational risk was equally serious. Exceed the bulb's 300-hour service life, and the assembly could fail catastrophically, sending glass shrapnel through the reflector housing. Crews tracked those service hours with the same attention they gave to main gun rounds remaining. The M103 sits at the end of this technical era as both an achievement and a cautionary note. Its 120mm gun was engineered to defeat anything the Soviets could field on the North German plain. At 65 tons, it exceeded the load rating of most European bridges and consumed fuel at a rate that made sustained independent operations nearly impossible. The Army warehoused its M103s in Europe. The Marine Corps, characteristically, put theirs to work, maintaining them in divisional service until 1974. The M103 was the final expression of the dedicated heavy tank doctrine, a concept the M60's arrival rendered permanently obsolete by unifying the firepower, protection, and mobility that had previously required compromises between categories. The specifications were sound. What they meant in the field was another question entirely. The 1954 Johns Hopkins study, Tank versus Tank Combat in Korea, produced a finding that the Army quietly internalized and rarely advertised. American tanks were 3 times more effective in combat than their North Korean counterparts. Not because the 90mm outclassed the 85mm by that margin. It didn't. But because American crews were consistently winning the engagement cycle. See first, acquire first, fire first. The M12 and M15 optics gave U.S. gunners a decisive edge over T-34 crews working with inferior Soviet glass inside a cramped fighting compartment that fatigued them faster than the terrain did. The gun that kills you first is the one you never saw coming. Korea proved that principle at scale. Vietnam proved something different entirely. Armor in Southeast Asia spent roughly 95% of its operational life not hunting enemy tanks, because there almost weren't any, but serving as direct fire support and mobile protection for infantry moving through terrain that had no business accommodating a 52-ton vehicle. The M48A3 became what veterans accurately called iron artillery. Its 90mm firing beehive canister rounds, each shell releasing thousands of steel flechettes on a programmable fuse, could clear a jungle ambush or stop a massed infantry assault in ways that called artillery could not match for speed or precision. When ambushes hit convoy columns, the response was the herringbone, tanks pivoting outward from the road in alternating directions, creating an immediate perimeter of fire that covered every approach simultaneously. The 11th Armored Cavalry Regiment, the Black Horse, refined this into standard doctrine through repetition and blood. What the manuals didn't cover was mud. Monsoon season mud in the Central Highlands could vacuum seal a 52-ton Patton into the earth with a suction that winches couldn't break. Crews learned, through field expedience and desperation, that detonating C4 demolition charges beneath the hull could shatter that seal well enough to allow extraction. It worked. It was also the kind of solution that exists entirely outside official documentation, passed crew to crew, rather than written in any field manual. Sandbags appeared on turret roofs for similar reasons. Improvised spaced armor intended to prematurely detonate the shape's charge of an RPG-7 before it could defeat the hull. Imperfect, heavy, standard practice. The Battle of Ben Het in March 1969 stands apart from everything else. Vaped 76 amphibious tanks probed the perimeter of a Special Forces camp, and M48 A3s of the 1st Battalion, 69th Armor, met them in the dark. It remains the only confirmed tank-on-tank engagement of the Vietnam War. The Pattons won it decisively, demonstrating that despite every environmental disadvantage, the M48 A3 remained the dominant armored platform in theater. The specialized platforms tell the war's more complicated story. The M56 Scorpion, 7 tons, a 90mm gun, and 0 armor, was deployed by the 173rd Airborne Brigade as a paratrooper anti-tank asset. In a conflict defined by snipers and mortars, its 4-man crew had nothing between them and incoming fire except the assumption that the enemy wouldn't find them first. Veterans who served alongside it were rarely enthusiastic. The M50 Ontos was a Marine Corps answer to a question the Army never fully appreciated. How do you bust through reinforced concrete in an urban environment when your 90mm shells are ricocheting off the walls? Thix 100 6mm recoilless rifles, fired in combination, solved that problem at Hue City in 1968 with devastating efficiency. The Ontos carried only 18 rounds and required the crew to dismount and reload in the open, a vulnerability its crews accepted because nothing else was punching holes through those walls. Its glance and dash tactics, fire, displace, fire again, kept it alive long enough to matter. The M67 Zippo flame tank operated on deception. Its dummy 90mm barrel was designed to prevent enemy anti-tank teams from identifying it as a priority target before it could close range. Once it did, it could project thickened fuel for over a minute, enough to saturate a bunker complex or collapse a tunnel network. The operational reality was grimmer than the capability suggested. The flamethrower's internal mechanism generated noise levels that made intercom communication impossible, forcing tank commanders to expose themselves above the cupola to hand signal their gunners during the engagement, in a firefight within RPG range. And then there was the Sheridan. The M551 deserves an honest accounting, because the veterans who rode in them will tell you exactly what it was. The aluminum hull that made it air deployable offered no meaningful resistance to an RPG-7 or a buried mine. In February 1969, a single mine strike destroyed a Sheridan so completely, so catastrophically, that the Army expedited a titanium belly armor retrofit program that should have existed before the vehicle ever deployed. The M51 Shillelagh missile system, the entire justification for the 152mm gun launcher combination, was effectively irrelevant in Vietnam. Enemy armor was rare, the jungle canopy disrupted guidance, and the system sat unused while crews relied on conventional HE and flechette rounds. The caseless 152mm ammunition, innovative on a test range, was volatile in the humidity of a Vietnamese turret, and the loader working with it in combat conditions lived with a risk the specification sheet never honestly addressed. The Sheridan was fast, its anti-bunker firepower was genuinely effective, and it was a death trap. All three things were true simultaneously. These machines, and the men inside them, produced lessons that could not be unlearned. What the Army built next reflected every one of them. The M103 was the last of its kind, not because the idea of heavy firepower was wrong, but because 65 tons of steel that couldn't cross most European bridges without engineering support had already answered its own question. The main battle tank concept that replaced it wasn't a compromise. It was a conclusion that firepower, protection, and mobility could no longer be treated as competing priorities to be distributed across separate vehicle categories. They had to coexist in a single hull, or the logistics would kill you before the enemy did. The M60 was that conclusion made steel. Diesel from its first production run. The 105mm M68, derived from the British L7, standard from the outset. Neither of those decisions emerged from a design philosophy meeting. They were extracted directly from M48A3 operational data returned from Vietnam, where gasoline burned and range limitations cost lives. The M48 hull itself proved sound enough that the post-Vietnam A5 upgrade, retrofitting the 105mm M68 into the existing turret, brought surviving Pattons to M60 equivalent firepower. The airframe was right. The lessons refined everything built around it. The Sheridan's failure left a gap in air-mobile armor capability that the Army acknowledged, and then spent decades struggling to fill. The M8 Armored Gun System program represented the most serious attempt to answer the question the Sheridan raised, and it was canceled in 1996. That gap arguably persists today. The Johns Hopkins finding from 1954 that fire control, optics, and crew training consistently outweigh raw gun caliber was written into every subsequent American fire control development program, from the M60A3's laser rangefinder to the M1 Abrams thermal imaging system. The lesson was never forgotten because the cost of learning it was too high to discard. If this kind of deep dive military history is what you come here for, subscribe now and turn on notifications. This community is built for exactly this level of detail, and there's significantly more to come. For collectors and historians, the M48A3 is the most operationally significant American tank of the Cold War era. Not the most powerful, not the most advanced, the most tested by terrain, by climate, by an enemy who forced it to perform roles it was never designed for, and by crews who made it work anyway. Surviving Ontos and Sheridan examples are among the rarest Cold War armored artifacts in existence. Their mechanical complexity makes preservation genuinely difficult, which means the ones that remain deserve serious attention. The men who drove these machines didn't read about them in archives. They checked the oil, tracked the service hours, and made decisions in seconds that this video has taken 20 minutes to explain. That gap between documentation and experience is worth remembering every time we study this history. The metal is what survived. The knowledge of what it demanded from the people inside it, that's what we're responsible for keeping accurate.